Of completing a square to do this. First, what we've seen so far this year are things that can be factored into something that looks like what's on the board, x minus p and x minus q, or we have those that are in the form x squared equals r. But we have to look at another method to solve the following equation. So what if we can't get something to look like this, right? What if we can't factor? Or what if we can't get it like this, where we could just take the square root? Then the question is, what do we do besides the quadratic formula, which comes from completing the square? Start with completing the square. So look at example A. For example A, you might be tempted to start by squaring or foiling on the left side. Or you might be tempted to say x minus 2, foil it out, and then solve. And you can do that, you can. But if an equation is ever set up like part A, it's actually much easier to solve if you do something else. What could we do for part A to start instead?
So you could get root 3 plus 2.
All right. Now, that's not exactly right, Charles. You're missing some stuff. So why don't you tell me what you're doing to both sides first?
So first you can square both sides. Well, you know, like radical, like root both sides.
Square root both sides. Got it?
Both sides. So you get x minus 2 equals square root of 3.
Now, that's where you're missing something. When you're square rooting something in an equation, you're trying to find the solutions.
Plus or minus.
Yeah, it's plus or minus. Got to remember that, right? When you square root, it's plus or minus for an equation, because you're looking for solutions, and there's two solutions. You're not simplifying an expression. Keep going, Charles.
So you can add 2.
And then add 2 to both sides. Now, traditionally, let me show you how this is written. Traditionally, you write this as 2 plus or minus radical 3. You add 2 to the front of it, not to the end. Okay? Again, doesn't really matter. It's the same answer if you had put plus or minus root 3 plus 2 at the end. It's the same thing. But traditionally, you write it because it looks like a complex conjugate or binomial conjugate. 2 plus or minus radical 3. This is a binomial conjugate, or a pair of binomial conjugates. So, the solution to this first equation, there are 2 of them. They are not rational. They are real. There's no imaginary number here. There's no I. And they are binomial conjugates. Let's jot that down real quick, because it's going to come up in the next few sections. This answer is real, irrational, and specifically, the 2 answers are complex conjugates. All right, so again, there's 2 answers here, 2 plus root 3 and 2 minus root 3. And those answers there are the solutions to the equation, but they're also, if you recall, the x-intercepts if you were to graph something like this. So you have one x-intercept at a location of, well, square root 3 is going to be less than 2, greater than 1. So it's 2 plus like 1.5. You have one intercept over here and one intercept over here. How about part B? Part B, no different than part A, right? You square root both sides again. So first I have 2x minus 5 quantity squared equal to 8. If I were to square root both sides now, what do I get if I square root?
2x minus 5 equals radical 8.
Forgetting one thing.
Plus or minus.
Thank you. Now, simplify radical 8 or start solving. Whatever you want to do first. Mike?
2 radical 2.
Yeah, 8. And you remember, Mike? Very good. I mentioned that. This is one of those ones that you might want to have memorized, but radical 8 is always radical 4 times radical 2. So it occurs a lot. Now, what do I need to do? Will, how do I get rid of that 5?
You add 3
I add it. So I'm going to put it in front on the other side to show that it's been added over there. Okay, again, just really, and this is where it gets a little tricky. When I add this 5, I'm adding it and I'm putting it here. There's really a plus in front of here, so add it. And then finally, then I want to solve for the value of x. Divide it all by 2. Now this just becomes radical 2 on the right side. Take a look. When I divide this whole thing by 2, right, I get 5 over 2. Right, this 5 over 2 right here comes into play. And then these 2's, what happens to them?
Cancel.
They cancel. Again, divide this 2 into here, you have to write 5 halves. But then you divide this 2 into here, this 2 cancels with this 2, leaving behind the radical 2. Alright, so we get 2.5 or 5 halves plus radical 2 and 5 halves minus radical 2. Again, how many answers do we have? 2 answers. Anybody remember why that is again? Luca?
Because in the original unvectored equation, there's an x squared.
Yeah. In the original, you have an x, and that quantity is squared. So if you were to FOIL out the beginning, you would have had a trinomial, or at least something with quadratic, where you'd have x squared. Good. Very good. Part C. Part C. What do you expect for Part C to happen? And I don't want the answer right away, but I want to know, what do you expect? What do you expect to happen? Luca.
Would you square both sides, it would be radical negative 4, which would lead to 2i.
Yeah, so what kind of an answer are we going to get here? Imaginary. It's an imaginary answer that we're getting. Now, for these problems, remember what I talked about. If you cannot factor, if you couldn't use, well, you could always use the quadratic formula, we're going to see that. Sometimes your answers aren't real. And so far we've talked about answers like this right here, where if you were to graph that answer, square root of 2, 1.4 is 2.5. So here's where your roots would be on here. Let me show you what this looks like. So 2.5 you would start at, and then go plus radical 2. So 2.5 is right over here, and then radical 2 is 1.4. So if I add, approximately, when I add 2.5 to it, I'm going to have one root here. Right, so I'm going to have one root right there. And then I'm going to subtract 1.4 from 2.5. That'll get me back over here to about 1.1. So what this graph would look like, I can tell you already, is this. All right, that's what that graph would look like from part B. Because my 2 answers I got were real, they were irrational, so they're not exact numbers, they're not integer values. And they show up on the graph, they're binomial conjugates again. Now here, when we get answers, Luca mentioned they're going to be mentioned that we're going to get a negative answer there, so we have imaginary as well instead. What's going to happen on my graph when I go to find those x-intercepts? Where are they going to be?
Look at the bottom of the graph. There's the bottom.
What do you mean? So if I were to draw the graph wheel, right? Where would I draw the parabola? Tell me.
Like, at the very, very bottom.
Yeah, so maybe something like this down here. Okay, at the very bottom, or at the very top, or like upward toward the top. But this answer, we're going to get a graph that would look like this, because when the roots are imaginary, it means that you have no real x-intercepts. So you do not have an x-intercept for a graph like this. So I can tell you already that by the fact that we have an imaginary solution here, your graph is going to look either like this, or maybe up here, or up here, but it's going to be floating. When I say floating, I simply mean there are no x-intercepts. All right? So we should know that already. So maybe jot that down for this one, that this would not provide any x-intercepts if you were to graph it. All right, so as Lucas said, we're going to square root both sides. And that's going to give me the plus or minus the square root of negative 4. Now, when I do that, I'm going to make that look nicer. When I do that, I have 2i, because square root 4 is 2, and the negative part is an I. So I can think of this, if I need to, like this, and then progressively write it down if it helps. Okay, but that's the process that you want to be thinking about. So remember, the negative comes out as an I. Square root 4 is just a 2, and it's plus or minus. With the plus or minus here still. How do I get rid of that 1? Now, how do I get rid of a positive 1? Subtract it, but where is it going to go? How do I put it in the front and still have it as a subtraction process? Remember, I want that number in the front, don't I? We talked about how this should end up right here, not over here. So I can't put minus 1 over here.
You just subtract that and then do negative 1 plus or minus 2i.
There it is. Put it as a negative 1. So write it as negative 1 plus or minus 2i. Because really, by definition, subtraction is defined as adding the opposite. So we're just putting the opposite of a positive one, which is a negative one out in front. Questions so far? Questions? All right, the fourth part is going to lead us into today's lesson. So what we've done really so far is just looked at like previews. The fourth part, part D now, is going to lead us into the lesson. So we've got x squared minus 4x plus 4 equals 5, negative 5. Now, you could try to move the 5 over, and you have a 9 here, but nothing multiplies to 9 that adds up to negative 4. So it's not going to work. You can't factor it if you did. So try to think about what we've been doing with the first 3 examples and apply that to this. Apply that to this. How could I make this look like what we've had in the last 3 examples? How could I make part D look like A, B, and C? How could I make it look like A, B, and C?
Square root the whole thing.
But you can't. There's no square around it. You need this to be something square to square root the whole thing.
Do
How
that.
could you make this something square? I've seen one hand so far, but I'm just waiting. I want to give you guys time to think. This is something you have to think about. How could you make this look like what you had in the previous lines? The 2 hands I'm seeing so far. What is this really?
Well, you could just factor it into like 2 groups,
I mean, what would those groups be then?
x minus 2 and x plus 2.
Close. You're almost there. What should it be on the right one? Luca, what do you got for the right one? What should it be?
X minus 2.
Yeah, they should both be minus 2.
Oh.
That's the key. Because if they're both x minus 2, isn't it really x minus 2 quantity squared? Right? Isn't that what this means? Doesn't this mean x minus 2, that quantity squared? Right? To me, if I see 3 times 3, it just means 3 squared. So if I could write this as the product of 2 factors of which are identical, those factors are the same, write it as the quantity x minus 2 squared instead. And now, doesn't this look like part C? Can't you square root both sides now? Remember you asked at the beginning now? Now I can square root both sides because I've got some quantity squared. So our goal in this lesson is going to be make the left-hand side some binomial squared. Alright? Try to make the left-hand side into a binomial squared. So you have to try and factor. Now, not every problem is going to be perfect. See, look at this. Isn't this nice? It factors so easily. What if it wasn't written this way? That's how we're going to discuss what's called completing the square today. It helps to make the left-hand side a perfect square trinomial. Okay? So let's go ahead and finish solving this, though. Finish solving this. Now, can you take the square root of negative 5? What can you take out, though?
I.
Yeah, you could at least take out the I. Then what should I do? What should I do after that? Add the 2 over. Okay, now, again, it's not really an a plus bi form because it's the root 5 is afterward, but you can leave it this way for this one because traditionally, again, remember I was mentioning to you, radicals are written at the end. But you could also think of this as 2 plus or minus root 5i. But if you put the I over here, right, over here, be careful that you don't extend your radical. It looks like the I is under the round. So close the radical if you're going to put the I on the end. But for stuff with square roots, leave them on the very end. All right, so let's look at example 2 now. That is a little more tricky. So example 2, if we look at this at first, can you write this as a binomial squared? Now, I see Luca shaking his head already. You can't even factor this. Try it. What's going to multiply to 3 and give you 10 when you add, or negative 10? Nothing is going to. Now, in the last problem, we made it work. We made x squared minus 4x plus 4. It was really nice. So, in this problem, we want to figure out what we can change the 3 to make this work. Look at the 3. Think in your head, what can you change it to? Don't actually do it, but think about what can you change the 3 to make it work. What number could the 3 be so that we could factor this into a perfect, or into a square of a sum or a square of a difference? Nobody? What number would work so that when you multiply two numbers, you get whatever would be really right here, and those same two numbers add up to give you this?
21.
Not 21, but very close. 25. Because if I think about it, if I make this a 25, can't I just factor this into x minus 5, x minus 5? What's negative 5 plus negative 5? And isn't that what the middle term is? Negative 10? So, think about it. Take the middle term, whatever it is, in any equation, have it. So I have the middle term, you get? Negative 5. But it doesn't really matter if you're going to square it, but negative 5. Then square that number, which gives you, as Sabine said, 25, right? That's the number you need. So to get a 25, how many are missing? We have 3. 22. So let's add 22 to both sides. So let's start by doing this, by adding 22 to both the right and left-hand side. Which seems kind of weird. You're picking an arbitrary number, but it's not really arbitrary. And now, as Ben discovered for us, we have something that can be factored into the square of a sum, or the square of a difference. Okay, so this is clearly x minus 5, x minus 5. $22 cannot be broken down further, so it's not even worth going anywhere with that. So we add the 5 over, and we leave it this way. So again, what we want to recognize is that we've created a left-hand side that is easy to work with. Okay? Same process over and over again. So what I'm going to do is, on the next slide, I think I actually gave an example of this too. Maybe I did, maybe I didn't. But I gave some steps. Or not. I didn't, okay. Let me talk about them, okay? So the general steps for, this is called completing the square. The general steps, step 1, is to first transform the equation so that the c value is on the right-hand side. So move this over to start. So for step 1, I would say move C to the right-hand side. And over here, what I'm going to do is I'm going to do an example of this as we go through it, okay? So take a look. Let's make believe our original was this. Put the original at the top. Let's say the original was 2x squared. Was this going to, yeah, this will work. Minus 16x plus 30 equals 0. Okay, let's say that was the original there. So move the c value over. I know everything's divisible by 2, so we're going to divide by it, but generally move the c over first. So we get this. All right? So we move that over so that we have nothing here, and then you can figure out what actually goes here. Now, we don't want a to have any coefficient besides 1 for this process to work. It doesn't work if it does have a coefficient outside of 1. So I need to always next, for step 2, divide by a on both sides. Doesn't matter what a is. Okay, it does not matter. Even if a is not divisible into everything, you still need to divide everything by a. So divide everything by 2. We happen to have an example that works nicely. We'll see one in a minute that doesn't. Next, what's step 3? Who understands this really well? Let's see. At this point in time, we need to figure out, right, what goes here. We need a number here still. Something's got to go here to make this factorable. How do I figure out what goes here? What did we do in the last example?
Take the middle, you take B and then
Very good. That's it, Charles. Take half of whatever's there now. All right, so take half of whatever b was and then square it. So what's b in this case now?
16.
B,
Um,
after we simplify, what was b? From here, though, Cal, from here.
okay.
So half of that is going to be 4. And then, oh, you're giving me c to add there?
Yeah.
Okay, yeah, 16, good. I asked what's half of b, though. You said 16, that's why. So half of b is negative 4, right? Half of this number is negative 4, and then square it, which is 16. So put a 16 here. But if I add 16 on one side, so I have negative 15 plus 16, which is just what? 1. Makes the right-hand side nice and easy now. Again, this is a negative 15, but I added 16 right here. If I add 16 on the left-hand side, I need to add 16 on the right-hand side, just like we did earlier. And now we have something that can be factored into a square of sums or a square of differences. So step 4 is to factor. Notice, here, write this note down. Put a little asterisk right here. Whatever you get as a factor, or whatever you factor this into, is always, always, always going to be half of whatever the new b value is. Again, if you look at the b value here, b value is negative 8. Half of that is negative 4. That's what this will always be, every time. Because the way you got this 16 was by taking half of this in the first place, wasn't it? You have this, you squared it, and added it here. The half of this that you're squaring is really what goes here. Because technically you're squaring this to get you to 16. So this will always be half of this. It's a little note you want to jot down. All right, and then finally solve for x. So we have 4 plus or minus 1. Well, I should write those as integers now because they're integer values. 4 plus 1 is 5. 4 minus 1 is 3. Bless you. Okay? Again, if you ever have an instance where you have an integer plus or minus another integer, please write out the answers. 4 plus 1 is 5. 4 minus 1 is 3. Does the process make sense? All right, it's lengthy for sure. But the cool part about this is that it can always be used. It doesn't have to be even numbers. You can build variables. You can have like other coefficients that are not numbers, that are actual variables there. And this is what gives us the quadratic formula. So not tomorrow, but after this test, we're going to start with the quadratic formula, and I'm going to derive it from this method. So look at an example here. So quickly move the 13 over. Mike, tell me what to do next.
Should you add the number you need?
Yeah, what's the number we need this time, Mike? Take half of b, because we don't need to get rid of a anymore. A is not there. What's half of b?
3.
Square that.
9.
So put a 9 on both sides. But when you add 9 to negative 13, you get negative 4. All right, add 9 to both. I should really put that below the equation. All right, plus 9 on both sides there. So on the left-hand side again, take half of b. What's half of b, everybody? What's half of b? 3. That's what's going to be inside this parentheses automatically. Whatever half of b is always goes in that parentheses. Since b was positive 6, inside the parentheses is a positive 3. And now solve. Square root of negative 4. We did this before. What is it again? I root 4. And root 4 is really just? Good. So just 2, not root 2. So we have 2 times I. Write yourself a note for that, Will, okay? Write yourself a note whenever you take a square root, not to forget to remove the square root there. Now we got to get rid of the 3, so subtract the 3. So negative 3 plus or minus 2i. Alright? Again, if you were to graph this, what would it look like on the graph? You could explain what would the difference be between this kind of something, or this kind of function, versus another type of function that's a real answer.
The x-intercepts will be on the x-axis.
Yes, or that you could say there will be no x-intercepts. Very good. Their roots are imaginary, therefore there are no x-intercepts. Okay, very good. There's one more. Try it on your own to finish off, and then you'll have a few minutes. All right, finish off with the last. Easy because you need to divide by a. All right, so step yourself through it. I'll try to put up an answer like maybe a minute at a time. Work yourself through this question. It's not easy. You got to move the c over, but you need to remember to divide by a. You're going to get a fraction, so it's going to be messy. Just try it, see how you do. I'll put up some of the steps in a minute. Sure. We're just going to look at the quick steps. What? Very good. Very good. Well done. You're going to get real answers. You're going to get a fractional answer and an integer answer. If you want to check. This is the part where I think people might get a little bit confused. So you divide by a, but then the question becomes, what's half of 5 halves? Remember, we have to take half of whatever b is and then square it. What's half of 5 halves, Luca? All right, as a fraction, though, it makes it a lot easier on you. It's half. How do you have a fraction?
Just half the numerator.
Or, not the numerator, Nina. Denominator. You can either multiply the numerator by 0.5, that's fine, but it's going to get messy, right? 2.5. So double the denominator. What's double 5? Well, sorry. What's half of 5 halves then? 5 fourths. Square 5 fourths. 25 sixteenths. So add 25 sixteenths to both sides. This is where it gets messy. Now, you might say, Mr. Howell, how the heck am I going to factor this? But what did I tell you? It's always going to be in the factor. It's the same thing is always going to be in there. Half of b. So what's half of this again? Half of 5 halves is 5 fourths. So this is going to be y plus 5/4 squared. It's always going to work out that way. So you don't even really need to know how to factor that. Just always take half of b and put it there. Now, here, 3 halves plus 25/16. Multiply 3 halves by 8/8. For a common denominator of 16, giving me 24 plus 25/16. 24 plus 25 is 49/16. Why is that convenient?
Perfect squares.
They're both perfect squares, so square root both sides. Square root of 49 is? And 16 is? All right. From here, take the 5/4, subtract it. Now, it might be tempting to leave it that way, but you do have a common denominator, so write it twice. -5 plus 7 is going to give me a positive 2/4, which is really 1/2. That's one of my answers. And then -5 minus 7 is going to give me -12/4, which is -3. All right, so again, I break this into this one being -5/4 plus 7/4. This one being -5/4 minus 7/4. Okay, so again, remember that if you have things that are common denominators, you can be simplified, so go ahead and simplify them. Now, fun fact, if you were to factor that original equation we had in the beginning, and you didn't use completing the square, this one could have been factored into 2x minus 1 and x plus 3. The original could have been factored into that, and look at your answers. What would this give you if you were to set it equal to 0? It would give you -3. Set this equal to 0. You would add 1 and then divide by 2, giving you 1/2. So if you solve this, God bless you, by factoring, you get the same answers, obviously. But again, completing the square is important when you can't factor. If you can factor, go ahead and factor. This was just a proof to you that you get the same answer here. Okay? All right, so make sure tonight you work on... so this homework